to Projects. In this video, we are going to explain the project TopicBERT, a topic-enhanced neural language model fine-tuned for sentiment classification. Introduction. Sentiment classification, a challenging task in data mining, is pivotal for understanding public sentiments on social events, marketing, and products. The emergence of automated sentiment mining tools has fueled the growth of effective computing, with applications ranging from election result predictions to personalized product recommendations. This project focuses on fine-grained sentiment classification known as ATSC. It predicts sentiment polarity towards a target term, addressing nuances in sentiment depending on the context. The existing neural network models, particularly attention mechanisms, are biased towards high-frequency words. The project explores recent efforts to refine attention mechanisms, develop ensemble applications, and leverage BERT-based frameworks. However, there is a need for improvement, especially for domain-specific tasks. And in response to current limitations, the project introduces TopicBERT, a novel topic-enhanced BERT language model. By incorporating global semantics addressing homonymy and polysemy and considering topic information at the corpus level, TopicBERT aims to improve sentiment classification tasks. Objective of the project. So, as I mentioned earlier, the primary goal is to achieve expertise in sentiment analysis, which involves understanding and interpreting the sentiment expressed in text data. This includes both positive and negative sentiments. And we aim to delve into diverse datasets, particularly hotel, restaurant, and laptop reviews, to gain comprehensive insights into sentiment patterns across various domains. This exploration enhances the understanding of nuanced sentiment analysis. And the goal is to utilize advanced feature extraction methods like counter-vectorizer, Keras processing, and transformer. This implementation aims to enhance the model's comprehension of textual data, capturing intricate details crucial for accurate sentiment analysis. And the goal also includes evaluating the performance of prominent sentiment analysis models, including BERT Small, BERT Large, and TopicBERT. This assessment involves employing varied embedding techniques to understand how each model performs under different conditions and datasets. Requirements needed to execute this project are software requirements. Software needed is Anaconda. Primary language used is Python. Front-end framework used is Flask. Back-end framework used is Jupyter Notebook. Database used is SQLite 3. And front-end technologies used are HTML, CSS, JavaScript, and Bootstrap 4. Hardware requirements needed are operating system of Windows, processor of i5 and above, RAM of 8GB and above, and hard disk of 25GB and above. Now we'll discuss the working modules of flow of work. So the first step is importing required packages. So in this initial phase of the project, essential packages are imported, including Pandas, NumPy, Seaborn, Matplotlib, NLTK, and others. These libraries facilitate data manipulation, visualization, and natural language processing, laying the foundation for subsequent analysis. The next step is exploring the dataset. Here, two distinct datasets, hotel, restaurant, and laptop reviews, are explored to understand their structure and features. This exploratory phase provides valuable insights into the data's distribution, helping researchers comprehend sentiment patterns across different domains. The third step is visualization using Seaborn and Matplotlib. So here, Seaborn and Matplotlib are employed for data visualization, aiding in the exploration of sentiment distributions across various aspects. Visualization is crucial for gaining a deeper understanding of sentiment trends and patterns within the datasets. The next step is data processing. In this step, the dataset undergoes thorough pre-processing to prepare the text data for sentiment analysis. This includes steps such as removing URLs, special characters, punctuation marks, stop words, and normalizing the data. Tokenization and lemmatization are also applied, enhancing the quality of the text for subsequent analysis. The next step is feature extraction. Here, advanced feature extraction methods such as counter-vectorizer, Keras processing, and transformer are explored. These techniques aim to capture intricate details from the text data, enhancing the model's comprehension for more accurate sentiment analysis. The next step is feature selection. In this step, feature selection techniques are implemented to identify and retain the most relevant features for sentiment analysis. This step ensures that the models focus on key aspects of the text data, optimizing their predictive capabilities. The next step is splitting the data to train and test. So here, the dataset is divided into training and testing sets, a crucial step for evaluating the performance of sentiment analysis models. This split allows researchers to gauge the model's effectiveness in predicting sentiment on unseen data. The next step is training and building the model. So various sentiment analysis models including BERT Small, BERT Large and TopicBERT are implemented. Each model is designed to capture nuanced sentiments and understand the context of the text. These models serve as the core components for sentiment prediction. The sentiment analysis models are trained on the prepared datasets, leveraging the features extracted and selected during the earlier phases. Training ensures that the models learn the underlying patterns within the data, enabling accurate sentiment predictions. And in the extension phase, advanced models such as LSTM and hybrid models are considered for further enhancement. Additionally, a user-friendly Flask-based front-end with authentication was developed. And the next step is Flask framework with SQLite for sign-up and sign-in. In this step, we integrate user registration and login functionalities into the Flask framework. Users can sign up by providing their information and subsequently they can securely log in using their credentials. This enhances system security and allows for personalized user experiences. So after signing in, users provide input through the front-end interface. And the user input text undergoes pre-processing steps similar to those applied during the training phase. The goal is to ensure that the user's input is prepared in a manner consistent with the training data. And the pre-processed user input is then fed into the trained sentiment analysis models. The models generate predictions regarding the sentiment expressed in the user's input. And in parallel with sentiment analysis, a latent dirichlet allocation, that is LDA model, is applied for topic modeling. This step aims to identify and extract underlying topics within the user's input. LDA provides a method for uncovering the main themes or subjects present in the text data. And the final results of the sentiment analysis and topic modeling are presented through the front end of the Flask application. Users can view the predicted sentiment, that is positive or negative, and the identified topics. Now we'll understand about the algorithms used. So the first algorithm built is BERT Small. Firstly, BERT, that is bidirectional encoder representations from transformers, is a powerful language model designed to understand and analyze text. BERT Small is a simplified version of the BERT model designed to understand the intricacies of words within sentences. Its streamlined design is particularly effective at capturing subtle nuances in sentiment. In this sentiment analysis project, we leverage BERT Small's capabilities to predict sentiment towards specific terms, harnessing its proficiency in understanding fine-grained contextual details. In contrast, BERT Large is an expanded variant of the BERT model with more parameters. This increased size empowers BERT Large to navigate complex patterns and relationships within textual data more effectively. Similar to its smaller counterpart, BERT Large excels in bidirectional processing and contextual understanding. In this project, we deploy BERT Large to evaluate its performance against BERT Small, investigating how the model size influences accuracy in sentiment prediction. And the next algorithm built is TopicBERT, BERT with topic modeling. So TopicBERT is an innovative fusion of BERT with topic modeling techniques. This approach combines BERT's contextual prowess with a broader understanding of the overall theme present in the text. By integrating topic information at the corpus level using methods such as latent dirichlet allocation (LDA), TopicBERT addresses challenges like homonymy and polysemy. In this sentiment analysis project, TopicBERT introduces a fresh perspective by considering not only the immediate context but also overarching themes, thereby enhancing sentiment analysis, especially for domain-specific tasks. Now we'll see the comparison graphs for laptop reviews dataset. So this is the horizontal bar graph comparing accuracies of different algorithms. In this graph on x-axis I have accuracy scores and on y-axis I have algorithm means. So accuracy measures the overall correctness of predictions, showing the percentage of correctly classified instances. This is precision scores comparison graph. In this graph on x-axis I have precision scores and on y-axis I have algorithm means. So precision measures the accuracy of positive predictions, indicating how many predicted positives were actually correct. This is recall scores comparison graph. In this graph on x-axis I have recall scores and on y-axis I have algorithm names. So recall measures the ability to identify all relevant instances, showing how many actual positives were correctly predicted. And this is F scores comparison graph. In this graph on x-axis I have F scores and on y-axis I have algorithm names. So F1 score combines precision and recall into a single metric, balancing accuracy and completeness in predictions. So the algorithm which is best performing in all the performance metrics will be used for predictions. Now we'll see the comparison graphs for restaurant reviews dataset. So this is the accuracy comparison graph. This is precision scores comparison graph. This is recall scores comparison graph, and this is F scores comparison graph. Execution of the project. To execute this project, first we need to open the code folder which contains the project source code files. So this is archive folder in which I have the required datasets with class labels on which we will train the models. This is static folder. This folder consists of files related to CSS, JavaScript and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML pages. And these are model files which contain algorithm information. These files will be loaded into the project code during runtime to utilize the trained models. And these are Jupyter source files. So these Jupyter source files contain a combination of code, graphs and outputs all in one place. Jupyter Notebook allows users to write and execute code in individual cells, making it a popular choice for data science. This is topic modeling Python main file, and this is signup.db file. This file is the database file used to store user information. So now copy the path of the code folder from the address bar of the file explorer. I'm copying it. Open Anaconda prompt. Use the command cd followed by a space and paste the copied path and hit the enter button. So this command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, localhost and port unless configured differently. Now copy the local link provided by the framework. I'm copying it. Paste it into any web browser. I prefer Chrome. And hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. So here we can see a sign up link, click on it. So if you are new users, we have to register first. Fill in all these details and click on register button to sign up. And if we already have an account, we can directly log in by clicking on this link. So as I already have an account, I'm clicking on this link. So here we have to provide our credentials, username and password. And click on login button. So it has redirected us to the classification page. So here we can see a enter your message box where we have to enter a message and the application will classify it as either positive or negative message. So I have entered a message here. Now click on predict button. It will take some time to load. So here we can see the result. So this is the entered message, and for this message it has classified it as positive. So here we can see the label. The text type is positive. And based upon these words, the application has classified this message as positive. Now click on home link. We'll try giving another text. I have entered another message. Now click on predict button. So here we can see the result. So the label this time is negative. So the application has classified this message as a negative message. And these are the words based upon which the application has classified the given message as negative. Click on home link. We'll try again. So I have entered the message. Now click on predict button. So here we can see the result. This is the entered message, and here we can see the classification that is positive. And these are the words dependent upon which the application has classified the given message as positive. Click on home link. We'll enter another message. So this is the entered message. Now click on predict button. So this time the application has classified the message as negative. And these are the words dependent upon which the application has classified the given message as negative. So similarly, we can upload any text and can get the classifications. Now click on sign out link. So the conclusion here is the project successfully explored and implemented innovative models such as BERT small, BERT large and TopicBERT, showcasing a thorough investigation into advanced natural language processing techniques for sentiment analysis. Leveraging BERT small and BERT large allowed for a nuanced understanding of sentiment, capturing subtle contextual details within sentences. The model's bidirectional processing capabilities proved instrumental in achieving fine-grained sentiment classification. And the incorporation of TopicBERT introduced a unique approach by integrating topic modeling information at the corpus level. This enhancement contributed to a more comprehensive sentiment analysis, addressing challenges associated with homonymy and polysemy in diverse textual contexts. And the project systematically evaluated the performance of different sentiment analysis models, including a comparative analysis between BERT small and BERT large. This rigorous evaluation provided insights into the impact of model size on sentiment prediction accuracy. And as an extension, the project explored ensemble methods and hybrid models, combining predictions from multiple individual models to enhance overall robustness and accuracy. This extension demonstrates a commitment to continual improvement and innovation in sentiment analysis methodologies.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.